Okay, first of all, let's talk about what is increasing and what is decreasing graphs. Okay, there's a really confusing concept, like the difference between strictly increasing and increasing. A lot of people, students misunderstand that and explain that in a wrong way. So today I want to go through that slowly and make sure you understand it. So what is an increasing function? Strictly increasing. Okay, just the word strictly. What's the word strictly doing here? Okay, a function f is strictly increasing on an interval if x2 is greater than x1. Implies that fx2 greater than fx1, which means, let's change that to an easy language. When x increase, my y value will increase. That's a strictly increasing question, strictly increasing function. So the other way, strictly decreasing is when x is increased, y value decreased. That's a strictly decreasing function. Okay, easy to understand. Going up is increasing, going down is strictly decreasing. We don't really talk about increasing and decreasing function in VCE, but a lot of, even some tutors misunderstand that because teachers in the wrong way. So what is actually increasing and decreasing function? Okay, strictly increasing is when x increases, y must increase. But increasing function can be when x increases, y does not decrease. Okay, y does not decrease, can remain the same. Okay, that's increasing, can be increasing function. What is a decreasing function? When x increases, y does not increase. It can remain the same, but it can't go up. If it go down or remain the same, it can be increasing or decreasing.
So y remains the same as
it can be not strict. No word strict, it's just increasing or decreasing. So for example, this part of the graph, it can be increasing or it can be decreasing. But it can't be strictly increasing or strictly decreasing. It's not, when x increases, your y remain the same. It doesn't increase or decrease. So it can be an increasing part or can be a decreasing part. But you can't use the word strictly. Okay, when you use the word strictly increasing, which means is this part. Well, strictly increasing can be increasing, but increasing cannot be strictly increasing.
Oh, okay, but what about the straight line? That's not
that can be increasing or can be decreasing. It's not strictly increasing. Because when x increases, your y, strictly increasing means when your x change, your y must change. Your y must change, but for the horizontal part, your y doesn't change.
So you can call it either.
You can call either. You can call increasing or decreasing, but you can't say strictly.
Okay, that's fine.
Yeah, you can't say strictly. So strictly increasing, the only part is strictly increasing is that linear, like the increasing linear. That's strictly increasing. Because your x increase, your y increase as well. That's strictly increasing. But all of this can be increasing as well. Because the whole function does not decrease. Again, the whole function when x increases, y does not decrease. But for part of it remain the same, for part of it actually increase. So I can say overall it's increasing. But if you go more detailed, the horizontal part it can be increasing, but the linear part can be strictly increasing. But the horizontal part also can call a decreasing function because it's not increased. So that's the difference between increasing, decreasing, strictly increasing, and strictly decreasing. There's no part strictly decreasing in this on this graph. Okay, there's nowhere strictly decreasing. But you won't be asked what is increasing function, what is decreasing function. This is not part of the VCE course. You only need to know what is strictly increasing. But why I'm talking about this? Because a lot of people think it wrong, okay? Give a wrong definition to them. That's why I want to clarify that first. What they mix with is this. This is a very important thing in VCE. So let's draw any cubic. let's say this point is A, comma C, that's B, comma D. Which part of the graph is strictly increasing? Like what interval this function is strictly increasing? And which part is strictly decreasing? Okay, that's my question. What interval is strictly increasing? What interval is strictly decreasing? What do you think for increasing? Negative infinity to A and union? Okay, my question is, do we include B or not include A and B? Or include one of that? Exclude? Not include. Yes or no? No. Okay, wrong. You must include it. This is the thing we test in VCE. You must include it. For strictly decreasing, you need to include that again. Endpoint, turning points must be included. Okay, even though the derivative there is 0, we still include it. I'll talk about the connection between the derivative later. But what you need to remember here, that's the part a lot of people explain wrong. Even on some reference books, this is wrong. A lot of them, well, because the course changed about 10 years ago or 13 years ago, something happens here. I don't know, a lot of reference book is not right. It says strictly increasing is not including the turning points, but increasing is including the turning points. That's a wrong explanation. Okay, if you hear anyone talk about that, that's wrong. They don't know what is the test, like what should be done for strictly increasing. There's no difference actually for strictly increasing or decreasing, or increasing, decreasing, because in VCE we don't test about increasing, decreasing. That's not part of the course. So therefore, turning point must be included anytime they ask for increasing, decreasing. Okay, so why I'm explaining what is increasing? Because I don't want you to have the feeling increasing and strictly increasing is one include the turning point, one exclude the turning point. Turning point needs to be included in any of that. Okay, increasing or strictly increasing, you need to include turning point anyway. So if you don't include a turning point, that's wrong. Okay, that's every year we put on the SAC. Every year students get this wrong. Okay, so that's why I want to make it clear now. You have this memory. If you're asking about increasing or decreasing, or strictly increasing or decreasing function, they are the same thing. In VCE, they are the same thing. No one will ask you for a horizontal line, whether it's increasing or decreasing function. But I just want you to understand what it really means by increasing and decreasing. So when we ask intervals, the interval must include turning points. I'll give you a really easy explanation to make you understand why I should include it. If you think about this point, A, B, C, D, E, F, do you think from point E to point A your x increased? Yes or no? Okay, F to C your y increased or not? Yes, so it is increasing function. When x increased, y increased as well, it's part of your increasing function. Satisfy the definition. Your x moved, your y increased as well. Satisfy. Okay, another example will be from B to H, P, like MP or MN, like that. From A to M, your y increased or not? A to M, your x increased or not? Increased? Yes. Y decreased? Yes. So it is part of the decreasing function. Both points will be the decreasing function. Satisfy the definition. So that's why the point A will be included in both increasing and decreasing function. It's more like a stair, you know, like you climb up and until the highest point and then you climb down. So from, if it's stair like this, from that step to that step, x increase, your y increase as well. That's increasing. But from this point to this point, the x increase, your y decrease is decreasing function. So this point will be included in both increasing and decreasing function. Clear? Is that clear? It's nothing to do with the derivative here. It's nothing to do with the derivative equals to 0 here. Okay, it's not, doesn't matter. Okay, so you may feel, or you may, yes?
Say it's very from the point A to C.
But your x decrease in this case.
So is that strictly decreasing?
No, you only look increasing x and then look at y. You only look at increase x and then look at what happens to the y value. Basically, you look from left-hand side to right-hand side. That's the definition for increasing and decreasing. If you learn something different, you need to correct this. Okay, so what I'm teaching here is definitely correct. This is the worst point because there's so many people teach it in the wrong way. Okay, so I hear so many students explain to each other, they explain the wrong way. That's why I know they think increasing is not including the turning point, strictly increasing is not including turning point, increasing is including the turning point. That's a really wrong explanation. I hear so many students explain to each other about this, and that's wrong. So what I'm teaching here is definitely correct, and that's the way you need to remember. And turning point needs to be included in both increasing and decreasing function. Okay? That's how we mark the SEC as well. That's how VCE mark it as well. Okay? Just remember that. Okay, really important because every year we have students doing something weird and it's not what I explained. So important, very important here. All right, then let's think about the derivative. Let's connect the increasing, decreasing to the derivative. When f dash x equals to 0, what that means? When f dash x greater than 0, what that means? Is increasing function, okay, or strictly increasing. Well, I can say that strictly increasing. When f dash x greater than 0 is definitely strictly increasing function. When f dash x less than 0, what you can say? Okay, strictly decreasing function. Okay, what f dash x equals to 0 can tell you? Yeah, can be flat, like can be a flat, can be just remain the same. Can be like this is the derivative equals to 0, like this horizontal part. Also, this turning point is derivative equals to 0 because the tangent is horizontal. This is the derivative equals to 0. Okay, that's the horizontal. We'll talk about that more for the next chapter, like about the stationary points. But think about this function. This function here. What's the gradient f dash x at that point? 0, because it's a horizontal tangent like this, is 0 as well. Do you think this function is increasing, decreasing, or part increasing, part decreasing? What kind of function is that? Strictly increasing. It's just keep increasing, right? Every x increase, your y increase. So for all the points, you move to the right, your y value will increase as well. So the whole function is a strictly increasing function. The derivative here is f dash x greater than 0. The derivative here is f dash x greater than 0. But the derivative at that point is f dash x equals to 0. But it doesn't matter equals to 0 or not. It's a strictly increasing function anyway over the domain R. There's no horizontal. It's always kind of increase a little bit. It's only stationary at the middle point. There's no way. Well, think about this is x cubed function. When you sub different x, your y must be different. Yeah? All right. So what I want to say here, or say if you have a function looks like this, is strictly decreasing, okay, overall, over domain R. But I still have a stationary points here, that's f dash x equals to 0. So what I want to say here, f dash x equals to 0 cannot tell you anything. Okay, information is not available. It can be increasing and or decreasing at that point. Because think about this point A. It belongs to part of the strictly increasing function, also belongs to the strictly decreasing function. So the point A is both increasing and decreasing function. But think about those two graphs here. is strictly decreasing, strictly increasing only for those two on the left hand side. So you can't really tell. It can be increasing or decreasing, or it can be the same, increasing and decreasing on the same function. So f dash x equals to 0 cannot tell us anything. You need graph to test. Okay, you need a graph to test about that. You cannot see that directly. So f dash x equals to 0 cannot tell you a certain information, but f dash x greater than 0 can definitely tells you it's strictly increasing. F dash x less than 0 is definitely strictly decreasing, no doubt. But f dash x equals to 0, I can't really tell. Okay, I can't really tell. Okay, that's the first part I want to talk about. Okay, that's the first part I want to talk about. It's hard? No, it's not hard, but it's just like something you need to remember. It's just go for that way. There's only one correct solution. Okay, there's only one correct solution for strictly increasing, decreasing.
It says here that the strictly
Yeah, so that, no, that's not wrong. That means for strictly increasing is when x greater than x2 greater than x1, this sign must be greater. It can't be greater equals to. The increasing can be greater or equals to, which means that's not decrease. Yeah, like for increasing, I can have x2 greater than x1, but fx2 can be greater or equals to fx1. It's not a strictly larger than. It just can be larger or equals to. So it means can remain the same. So that's not rather than this one. That's what is talking about here. Okay, that's the first part I want to talk about. Any questions here? Okay, then let's talk about the second part. Second part is how we sketch f dash x from fx. Okay, how to sketch f dash x from fx. Give you the graph of fx function. How do we sketch f dash x function? Okay. Let's think about that first. How do we derive x to the power of n? Derivative. We think about derivative. Yeah, n x to the power of n minus 1, right? So if the original function is a cubic, what's my derivative function becomes? So that's a quadratic. Okay, if the power 4, what the derivative function becomes? A cubic. So it's reducing power. Okay, it's reducing power. Well, in year 12, we talk about more f dash x for any graph, not only polynomial. It can be any random graph and then sketch for f dash x. But in year 11, we only talk about polynomial derivatives and only talk about the graph for polynomial. So what kind of graph is this one? A cubic. Okay, a cubic. So what's the derivative graph should be? Yes, a quadratic. Okay, what we need to look at to sketch f dash x from fx is first, look at stationary points. What are stationary points? Derivative equals to 0. Okay, so gives you f dash x equals to 0. Okay, what kind of points is stationary points? Turning point or stationary point reflection? Okay, so those two types is stationary points. So now I'll use the red pen to sketch this. The turning point is here, right? The turning point is here. So at those two x value, I will have that as x-intercept. Okay, that's the x-intercept. Okay, why is x-intercept? because the derivative equals to 0. Okay, the derivative equals to 0. So what I know is turning points becomes x-intercepts. And stationary point of inflection, okay, that's a little bit special. That will become x-intercepts as well. And also that will become turning points. Okay, so it's a turning points as x-intercept. So something like this. Okay, it's the x-intercept and it's also the turning point. So stationary point of inflection will becomes x-intercept, but also will becomes turning points on the x-axis. Okay, that's the first thing we need to do. Second, think about the decreasing power, x to the power of n to n times x to the power of n minus 1. Think about the decreasing order of the function. So what we have here is cubic, right? What I will have is a quadratic. So I know my graph should be a quadratic. Well, I have two types of quadratic. One type is the increasing one, that one is through the 2x-intercept. The other one can be a decreasing one, okay, through the 2x-intercept. So what kind of graph I should have? I need to decide. Shape. So by looking at increasing or decreasing. Okay, let's look at the 2 point in between this part of the graph. Is that a decreasing or increasing function? Decreasing. Then derivative needs to be what? Less than 0, right? So less than 0. That means f dash x greater than 0 if it's increasing. Then it's above x-axis. The graph is above x-axis. But if f dash x is decreasing, it's less than 0, then it's below x-axis. Well, it's a gradient because that's fx, f dash x, and the x graph. So above x-axis means derivative is positive, below x-axis means derivative is negative. So in between the 2 points, do I have negative or negative derivative, right? So it should be below, okay, below the x-axis. Right below the x-axis, in between here to here. So my graph will definitely look like this. I don't know the exact scale, but it's something like the shape will be this. Why that? Because in between a and b is decreasing function, so my derivative needs to be negative. And in between b and infinity is increasing function. My graph needs to be above x-axis. And that's the only way I can sketch a quadratic and satisfy all of that conditions. Yes? Nothing. Well, I don't know the coordinates here. If I know the coordinates here, then I will know what's the x-intercept. It's just the same x value as that point. No, I can't. It's just a rough shape. Like what the derivative function will kind of look like. It can be dilate, stretch, even move up and down a little bit, but not moving up and down. It's just it can go dilations.
I don't understand how you got like that the turning points become the
Turning point is derivative equals to 0. This pink graph is the f dash x graph as well. So when x equals to b, your derivative is 0. Yeah, it's the vertical axis is the f dash x. Yeah. Okay. Let's have a look at the function, page 11. Okay, so for the first graph is a horizontal line. What's the derivative here? 0. So my derivative is a horizontal line on the x-axis. Okay, it's the line here. The derivative is 0. That's why f dash x equals to 0. Okay, what's the derivative for the next one? You have 2 points there, okay? You have 2 points there. What's the derivative for that? One minus 0, 0 minus negative a half. What's that? Yeah, what's 1 over half? 2. Okay, so this function is y equals to 2x plus 1. So what's the gradient function looks like? 2, y equals to 2. So it's f dash x equals to 2. It's still a horizontal line. Okay, what's the next graph? Quadratic, right? What's the derivative function will be? What's the derivative function will be? Linear. So I have local minimum at 2, 1. So I will have x-intercept 2. Okay, I will have x-intercept 2. Is that an increasing function or decreasing linear? Well, my linear can be this way, or it can be this way. Is that an increasing linear or decreasing linear? Increasing, because this side is positive, this side is negative. So I will have graph of both and I have graph below on that side. So the graph must be this. Like it can be any gradient because I can't really know the gradient, but I need a positive graph. It can be more steep like this, but I don't really care. As long as you can draw the shape correct and with the positive negative correct, that's all good. Okay, next one. That's a cubic. So I will have minus 1, 0 and 2, 0 as my x-intercept. Well, the scale is really bad. It's too tiny. Do I have an increasing quadratic or decreasing quadratic? Increasing. Okay, increasing. That shape. Because, let's see, in between negative 1 and 3, I have negative derivative. So in between 1 and 2, oh, negative 1, 2. So I have negative derivative below the y-axis. And then on the right-hand side of 2 is an increasing function. So on the right-hand side of 2, I have graph above the x-axis. And same as the other side, I have graph above the x-axis. So it should be an increasing function. Okay, let's look at this. This is a cubic. I have x, like the stationary point is 1, 0. So I have 1, 0 here. Okay, it will be 1, 0 as well for me. That's the stationary points. But remember, this is a stationary point of inflection. So this point is also a turning point. This point is also a turning point. Is that an increasing function or decreasing function for the original one? Increasing. So every gradient needs to be positive, right? So what I sketch is this. Okay, it's a positive. It's all above the x-axis, nothing below the x-axis. So I will have a quadratic, but with turning point at 1, 0. And 1, 0 is also the x-intercept. Let's have a look at the next one. Well, it's kind of a polynomial, but I don't know what's the degree of that polynomial. But what I will know is negative 1, 0 is one of the x-intercept. 1, 0 is the other x-intercept. But 1, 0 needs to be a turning point as well. Okay, 1, 0 needs to be a turning point. That's the stationary point of inflection. Okay, that's the stationary point of inflection. Okay, think about the graph. negative 1, okay, after negative 1, the whole function is increasing, is that right? Yes, whole function is increasing after 1. So at least you know after negative 1, my graph should be this. That's the turning point. Okay, it's all above the x-axis. But what do you need for negative 1? You need something like this. The graph will look like this. Okay, after negative 1, the whole graph needs to above the x-axis, and also it needs to have turning point at 1, 0. That's how you will sketch it. But on the left-hand side of negative 1, the derivative is negative, so you need to go down after negative 1 on the left-hand side. So you have negative there and no positive. It's not decreasing, your gradient is positive. Because, okay, your gradient is decreasing, but your gradient is still positive. If it's a positive gradient, it means it's increasing function. You not look at this graph to decide it's increasing or decreasing. You look at your original graph to test it's increasing or decreasing. Whether it's increasing, decreasing here, in method it doesn't mean anything. In sketch, yes, it means something. But in method, it means nothing. You just need to look at it above x-axis or below x-axis. Okay? Okay, everyone. One more exercise. Question? Okay, what I want to talk about here is, I want to talk about one thing, is you have a function. Okay, let's say we draw a graph. And then we draw a tangent at a point. Let's say this point is point A. Okay, draw a tangent at that point. And this tangent will make an angle with the positive x-axis, angle theta here. And this linear, like this tangent will have an equation y equals to f dash a, well, I will say mx plus c. But what's this m equals to? This m equals to f dash a, because that's the gradient of the tangent, which is the derivative. But what m also equals to? That also equals to tangent theta. Yes, tangent theta is the gradient. So what we can see here is tangent theta will equals to f dash a. Then theta will equals to tangent inverse of f dash a. And you can put that into the test, and you will work out the angles. Okay, the angles. Sometimes it will ask you what's the gradient, what's the angle made with the x-axis and the tangent, and that's how you work out that. It's nothing related to this example here, but that's just something you need to know. Okay, that's just something you need to know. All right. Is separate question here. Okay, it's nothing to do with the question. Okay. A really quick example here. Find the coordinates of the points on the curve with equation y equals x squared minus mx plus 8, at which the tangent line makes an angle of 45 degrees with the positive direction of x-axis. What's this 45 degree tells you? Well, it's a little bit connected to what I'm talking about here. So what's the 45 degree tells you? Gradient equals to 1. So f dash x equals to the tangent 45 degrees. And that equals to 1. So at a point, you draw a tangent, and this tangent make an angle 45 degrees, and that's a derivative equals to 1. So, well, it's dy dx. My dy dx equals to 2x minus 7. And that equals to 1. So my x equals to 4. So it wants to find the coordinates. So the x coordinates is 4. The y coordinates equals to 16 minus 28 plus 8. That's y equals to minus 4. So the coordinates is 4 minus 4. So at the point 4 minus 4, you will have a tangent line make angle 45 degrees with the positive x-axis. Okay, so what you want to find is what x value will have a derivative equals to 1. So at 4, the derivative equals to 1. So at 4, what's the y value? I sub 4 into the function and then find the y value. That's the coordinates. Okay, if you look at B, you want the tangent of the graph parallel to the line y equals to minus 2x plus 6. What that tells you? Same gradient. So your dy dx needs to be same as negative 2. They can be parallel, which means the gradient is the same. So your dy dx equals to negative 2. Which is 2x minus 7 equals to negative 2, x equals to 5 over 2. Huh? 2x minus 7, the derivative. First one. That's your gradient function. That's your gradient function. So when x equals to that, you want to work out the y value. So it's 25 over 4 minus 35 over 2 plus 8. So 8 is what? 8 is 32 over 4. That can be a 70 over 4. So that's 57 minus 70, that's minus 13 over 4. It's minus 13 over 4, so coordinates is 5 over 2 minus 13 over 4. I hope I haven't calculated wrong. What's the question? Why do I need to do? Because it's talking about the tangent. It's nothing to do with that graph. It's like we have a graph, and I'm talking about the tangent of each point. The gradient is the derivative. It's not the graph, it's the derivative. It's the tangent of the gradient. The gradient of the tangent is the derivative. So that's why I need to say derivative equals to 2. Derivative equals to 1.
Is there any sign like the derivative, like a triangle or something?
dy dx, f dash x. Yeah. Alright, everyone. For the next 20 minutes, you need to complete example 3 by yourself. That's the same thing as the previous one. So you do example 3 by yourself, and tomorrow we'll start exercise G. Wait, one by one first. Which one? Oh, what angle you make to fly? Like which way it goes. For example, if the flying path is like this, okay? So at this point, well, the motion of direction change every single time, like you consider. So at this time, like it's trying to fly this way. It's the tangent of the graph. So you look at what angle you make with the horizontal to fly. 45 degrees in the horizontal, or like 135 degrees which way. It's not a nice number, so it's a decimal number. So, for example, 57.9 degrees, which direction? Well, 1 decimal places. Yeah? Later, yes.
Today?
Yes.
Oh my god.